Now that we're familiar with all technical terms and procedures we learned in Chapter 8.1 and in our previous video, Basics of Hypothesis Testing, we're well prepared to put our knowledge in practice and test the hypothesis about the population proportion. Let's read the following example. A study of sleepwalking or nocturnal wandering was described in Neurology magazine, and it included information that 29.2% of 19,136 American adults have sleepwalked. Use 0.05 significance level to test the claim that for adult population, the proportion of those who have sleepwalked is less than 0.3 or 30%. We're going to use the steps or procedures for the hypothesis testing we went over in the previous video. First step is to identify the claim. And here is our claim that for adult population, the proportion of those who have sleepwalked is less than 0.3 or 30%. Now step 2, write the claim in symbolic form. We're talking about population proportion. P is less than, we're using sign less than 0.3. Now, before we go to step 3 to identify null and alternative hypothesis, let's identify the opposite claim. The opposite of the claim that P is less than 0.3 would be P is greater or equal 0.3. Now we're ready to write the null and alternative hypothesis. Remember, null hypothesis is the one that has the equal statement. P is equal to 0.30. The alternative hypothesis would be our original claim. P is less than 0.30. Next step is identify significance level. We are given significance level 0.05. So we're going to use alpha of 0.05. Next step is to identify the test statistic. Since we're dealing with population proportion, our test statistic would be Z. Z is equal P hat, which is our sample proportion, minus P divided by the square root of P times Q over N. Let's use the formula to find test statistic first, and then I'll show you how to do the test hypothesis testing using the graphing calculator and using StatCrunch. P hat is our sample proportion. Sample proportion is 29.2%. Therefore, P hat is 0.292. 0.292 minus population proportion P is 0.3 divided by square root of P is 0.3. Q is 1 minus 0.3, which is 0.7, divided by N, 19,136. Let's use the calculator to perform these calculations. I'm going to use graphing calculator. Open parenthesis, 0.292 minus 0.3, close parenthesis, divide by square root, so it goes second to get to the blue, square root of 0.3 times 0.7 divided by 19,136. enter. Our test statistic is -2.4149. Remember, test statistic is rounded to 2 decimal places, so it will be -2.41. -2.41. Next step, we want to perform the calculation using p-value method and the critical value method. Let's first use the p-value method. We're going to use the graphing calculator first. In the graphing calculator, you go to Stat, Tests, then scroll down to 1 proportion z-test, number 5. Click enter. You will enter your null hypothesis, which is 0.3. Then you will enter x values. We need to calculate what is our x value. Let's do it here. We have 29.2%. So we want to know what is 29.2% out of 19,136. And let's write 29.2% as a decimal. Move decimal point 2 times to the left. Use the calculator. When we use the calculator, we get 5,587.7. And of course, we're talking about population of people, so we round to the next whole number, 5,588. Let's go back to our graphing calculator and enter 5,588 as x value. Our n is 19,136. Go down. This row, we will find the sign in the alternative hypothesis. Our alternative hypothesis is that p less than 0.3. Therefore, choose the sign less than, then go down to calculate, click calculate. On the screen you can see the z-statistic -2.41 and the p-value. Let's write it down. P is equal to 0.007967. We rounded to 3 decimal places. I'm going to write it here. P value was equal 0.007967 rounded to 0.008. Now, we're testing the hypothesis using the p-value method. Remember, when we use p-value, we compare our p-value with alpha. Alpha, in this case, was 0.05. If the p is low, the null must go. Therefore, p-value 0.008 is less than 0.05, our alpha. If it's less, we reject the null hypothesis. Reject null hypothesis. To restate the decision in simple, non-technical terms, we use this table to help us. The condition was the original claim did not have the equality. Remember, our original claim was that p is less than 0.3. Therefore, original claim does not have equality, and what did we do? Well, the p-value of 0.008 was less than alpha, was less than 5%. So we reject the null hypothesis. Therefore, our conclusion is there is sufficient evidence to support the claim that, and we go to original claim, that for adult population, the proportion of those who have sleepwalked is less than 0.3. Here's our conclusion in non-technical terms. There is sufficient evidence to support the claim that less than 30% of American adults population have sleepwalked. Now let's look at how to perform the hypothesis testing of the population proportion using the stat. To perform the hypothesis testing for the population proportion in StatCrunch, go to Stat, go to Proportion Stats, One Sample with Summary, enter the number of successes. Remember, 29.2% of 19,136 was 5,588. Total number of observations, 19,136. Hypothesis test for P. Null hypothesis, 0.3. P equals 0.3. Alternative hypothesis is P less than 0.3. Don't worry about these steps. We go to Compute, and we find that Z statistic is also from the StatCrunch negative 2.41, and p-value is 0.008. The same values we found previously using the graphing calculator. We're going to use the critical value method. Let's draw a standard normal distribution just to help us visualize. Remember, our alternative hypothesis and our original claim was that p less than 0.3. Since it's less than, our critical value is going to be, and our critical region is going to be on the left. So we need to find this value, the z value that separates the critical region from non-critical region. The significance level we chose was 0.05. So let's find the z-value that corresponds to the area to the left of the z-statistic, to 0.05. I'm going to use table A2, negative z-scores part. 0.05 will be in between these two values. Let's scroll down and see what the z-score is. It's negative 1.645. Negative 1.645. Now remember the z-statistic that we got from the calculations was negative 2.41. Where is negative 2.41 located? Well, that would be smaller than negative 1.645 because we're talking about negative numbers. And our z statistic would be right here, negative 2.41. Can you see that it's located in the critical region? Since our test statistic is located in the critical region, we reject the null hypothesis And based on the wording of the conclusion, we can say that there is sufficient evidence to support the claim